Good morning to you. Mark Sudduth, HurricaneTrack.com here. Monday now, the 11th day of September 2023. And we've got some very important updates to talk about from the overnight runs of the models, the GFS, the ECMWF in particular, raising some concerns here that we might have sensible impacts, meaning impacts that you can actually feel, see with your eyes, that kind of thing. Yes, possibly for New England. Definitely time to pay attention up there. Not time to panic or worry or get upset about it, but definitely time to really focus in now. The weekend's over, football's over, got the work week ahead, got to focus, all right? Got to focus on this. And, of course, Atlantic Canada. We don't want to leave them out at all, but really the huge population center of New England. We need to be really watching what happens with Lee over the coming days, and I'll explain as we move along in today's update, all right? Thanks for tuning in. Let's get started. First of all, the ACE score. This is pretty remarkable. 80 right now. Normal is 60, so we are well ahead of where we should be. And this was well advertised several months ago by the different models, different agencies. And we're probably going to end up the season hyperactive because we've got Lee out there, and we've got a couple other systems to watch in the coming days, and it's only the 11th of September. We're not even halfway through the month yet. So we're at 14 named storms. There's 13 that have actually been named. There's one extra that happened in January, but it doesn't get a name. It's hard to explain, but we're at 14. We've had 4 hurricanes, 3 major hurricanes. All of the metrics except the named storms are headed towards where we thought things would be in terms of how busy. But 14 so far, and it's only the 11th of September. That's pretty much what we were thinking would happen. And a lot of it, pretty much all of it, is owed to all of this very warm water that we see relative to average. These are your anomalies. That word is very important. The departures from average still holding strong, but it's really, really neat. Let me show you this. That is what Lee has already done right through here. That is what Franklin carved out, okay, taking heat out of the tropics. There you go. And then that is the cold wake left by Idalia. And then in the Eastern Pacific, we have our El Nino here. But we have really chiseled away these extreme anomalies that we have. They were like the color of my telestrator here. It was off the scale, solid black over here several weeks ago. Those have trimmed back. We've expanded some of the warmer anomalies in the true Nino region, as we call it, the 3.4 area. So we're definitely in a significant El Nino, but overall the Atlantic here is warmer than the Pacific. So this gets the plus sign. I don't know what you even call this. I mean, this is positive as well, but this should just be bold, right? This is more positive. So we'll do 2 pluses. So that's why we have what we have, and it was well forecast, and here we are. So what does it all mean? Well, we're going to break that down for you. We got Lee out here, now a Category 3 again, strengthening again. We have Margot on its way to becoming a hurricane. We have a couple of areas to watch out here, 97L, and then we have another system over here over the eastern tropical Atlantic that could develop in the coming days. If we look at this over the next 5 days, 97L, not very well defined, very low chance of development. But this one, which would be 98L eventually, yeah, we'll definitely need to watch and see, but it's nothing to worry about right now. I know all of you that look at the models way out into the future have seen what the possibilities are, and that's good. I'm glad you're paying attention. I really am, but don't worry about it right now. We've got to focus on Lee, which, of course, the forecast here takes Lee up into the western Atlantic between Bermuda and the eastern United States. This is the latest 5-day forecast, subject to change, of course, and we have to just wait and see how things evolve beyond the next 5 days. We're getting close now to where we really have to start paying attention to this for our friends in Nova Scotia, up in New Brunswick, down through Maine, New England, maybe Long Island, right? Rhode Island, Connecticut, possibly. And then for the rest of us down here, and then everybody included, let's use a little bit less threatening color. Let's use this sky blue. We're going to have this rip current threat all through here with large swells dangerous waves, that kind of thing. They're going to be great for the surfers, as I have mentioned, but you have to respect that power. You really do. So this is interesting to me. I want to look at the wind speed probabilities for you real quick. Just now starting to get those wind speed probabilities between 5 and 10% of tropical storm force winds reaching southeastern New England, southeastern Massachusetts, Nantucket, Martha's Vineyard, and the Cape, inner and outer. Now, let me just talk about something real quick. I've been up there numerous times since 2014 for big nor'easters, the bomb cyclones, just your regular powerful nor'easters. And that's always really interesting. The wind is howling, it's cold. You get the big waves in Scituate and Marshfield, over in Dennis and Sandwich and Sassuat Harbor, Chatham, elsewhere, right? That's wintertime. I always think of it as practice. Knowing people, knowing places, getting that practice in. It's a long way to drive from Wilmington, North Carolina up to Massachusetts. Maybe it is practice for what's coming up potentially this weekend. All right? So now that these wind speed probabilities, it's low right now, but it's on the coast there. We're seeing that starting to, even almost to the extreme tip of Long Island there. So time to watch, time to pay attention, time to start really thinking, all right, this has a little bit more chance of happening. And we're not talking about the center passing by. And if you go and look at the model, what are they talking about? You look at the models, you look at whatever, and you see that center go by and it's well offshore, and you go, hogwash, they're just trying to scare people. If you focus on the center only, I don't know what to do. Okay? You got to really, come on. You have to think beyond that. Let's just go back to the satellite presentation here and show you, right? Let's look at this. That is the hurricane, not that. That's the eye. That's the center. And if that's going to be like over here, possibly in 5 or 6 days, and you go, dude, it's well offshore. What's the big deal? That's the big deal. The rest of it. And I laugh because I know. Because I've been through this. I've done it for 30 years, and I know the possibilities. That is the threat. That's the hurricane, and it is only going to get larger. It is going to unwind and disperse the energy over a larger area, and I'll be able to show you that visually in just a few minutes with some of the model output. All right? Swells are already a problem. This is from my hometown, Wilmington, North Carolina, and the Weather Service office here. Life-threatening, dangerous. You got to hit it hard. This is a problem. People could be injured or killed if they are not extremely careful. Right now, we're only talking about a moderate risk in the Cape Fear region. But elsewhere in my old stomping grounds, and even current, because I do take the family up to the southern Outer Banks from time to time, Cape Lookout, National Seashore, and the Outer Banks themselves. High risk out there. This is a big deal. This is real. This could be really problematic. So please pay attention. Luckily, school's in, and hopefully most kids are at school and people are not vacationing and whatever. But if you're out there, this is the real deal. You got to pay attention to this, all right? Sorry, I got something in my throat. It's like you get an itch in your throat. It's very annoying. So really do pay attention out there. If you're headed down there, even if you're a good surfer, you've been doing it for a while, these swells are just going to get bigger. So let's look at the modeling here and see what has changed overnight. This is the GFS. This is the 6Z run, meaning it was initialized at 2 a.m. Eastern Time, all right? And we're looking at the mean sea level pressure, which makes sense. We're right at the surface. And, excuse me, the 10-meter wind, which is about 35 feet up, something like that. There is Lee, there's Margot, and there's some energy sitting out here. We'll worry about that later. So watch what happens on the 6Z run of the GFS. We're going to take this out to 120 hours, which is right there. Parks a fairly decent-sized hurricane. Look at that wind field southeast of Massachusetts. And then if we just go out one more day, look what happens. It kind of pinwheels towards the coast a little bit and then makes landfall around day 6 in Maine. That would be extremely rare for sure. And you say, well, that's just a one-off run. Come on, man. Well, let's see what the 0Z did. Did it do something similar? Absolutely. In fact, it was a little bit closer to Massachusetts before just ducking east up into the Bay of Fundy in the area between Nova Scotia and New Brunswick, right? So you see what's happening. But look at that. Look at how big that gets. We focus on the center way too much. The center's right in there, right inside that little hatch, that cross there that Dr. Cowan has put in as a tool to see latitude and longitude. But look at the wind field expand. That is the hurricane. Look how big that is, how wide that area of winds are. Wow. And that whole thing moves up, this huge wind machine along the eastern seaboard, gets pivoted in. I'll show you why it does that in just a little bit. And if we zoom in, just to give you an idea of how that could impact New England, there you go, 50 knots and up. Strong northerly winds blowing across Cape Cod Bay. And wow, that could really, really be a problem. And this is just about 6 days out. It's not 8 days, it's not 9 days, not 2 weeks. And if you just look at 120 hours out, 5 days, which is what the forecast from the National Hurricane Center shows, right? Theirs is a 5-day forecast. It's just a little bit faster than the current 5-day forecast. Not by much, maybe. Large eye, the energy spreading out, that is what you need to focus on. Not the little geographic lat-long center. That's just the center. That is the hurricanes. That's what we need to focus on. Waves, storm surge, erosion, and it is going to be a problem for a lot of people here along the Atlantic seaboard of the United States and eventually Atlantic Canada. That's coming. That's a guarantee that there will be impacts. How severe they will be, we don't know that yet. So now let's look real quick at the wave setup. This is amazing. Look at this. This is the hurricane now. Watch how that wave energy expands over time. Holy moly, that is really, really incredible to see. Tremendous wave energy. And then it really gets focused up here. We go in again, we look at the northeast U.S. Are you serious? Look at these waves coming in just offshore of Cape Cod, heading up towards the area of the Gulf of Maine. Some of these wave heights seriously approaching 29 into the 30s. This pink area right in here, I mean, we're several gradations in, 30 plus feet. That's a 3-story house. And, you know, well, Mark, that happens all the time in those big nor'easters. Yeah, but this isn't a big nor'easter. This is a transitioning tropical cyclone that'll be influenced by atmospheric phenomena. We call that baroclinic processes. And it's summertime. This is going to be September 16th. It's the peak of hurricane season. This is going to have a lot more energy overall, plus the rain probably on the northwest side. So we have to take this very seriously. You see that coming up there? Man, oh man, oh man, that is going to be something else. And those waves will affect a lot of the Atlantic coast. It really will. So that's what we're looking at. Now, the Euro, this is perhaps the most important part of the video right here. I want to show you something really, really important. I call this like maybe a big key to how all of this evolves. Something that jumped out at me. I look at these things, I go back and forth almost obsessively. It's part of my work, it's part of what I do, and you try to notice something that jumps out at you. Does anything grab you? You look at patterns. They've made movies about this, where people can see things with looking at stuff repetitively. Some of it's to the extreme. Hopefully I'm not quite there yet in some of those movies. You know what I'm talking about probably. Think of Rain Man and maybe The Imitation Game, and where these geniuses, because I'm far from that, see things, right, in patterns in science and math. This is just more visual. And I do that a lot with time lapses, with clouds, and just all sorts of things. And so what I saw was like, that could be a real big key. It could be nothing, but it could be everything. Here's what it is. So these are your height anomalies at 500 millibars. about midway up through the atmosphere. ECMWF, let's use a color that pops a little bit better, shall we? Yellow, that works. Kind of like a highlighter, right? 500 millibar geopotential height and the anomaly, the departure from the norm. So these contour lines here, we call these height lines, measure the atmosphere like mountains. And just a real quick meteorology lesson for you. My degree is in geography, but in geography I studied meteorology and climate, right? So I'm not a degreed meteorologist, but I do have meteorological training, just not the math and the physics and all of that. So understanding the atmosphere is a lot like understanding our world, the surface of it. Now we're talking about the atmosphere, and it's made up of mounds of air and mountains of air and valleys of air. So this is your Western Atlantic Ridge out here. Part of it is fractured, and there's Lee. All right, and then you've got this trough, this little energy up here trying to dig in and erode that, and everything's moving along just fine. This is the 0Z, by the way, ECMWF. The overnight run initialized 8 p.m. last night. So let's move this on through time. And one big reason why Lee slows down, by the way, is it kind of runs into this over here. This is thicker. This is a thicker mound of air than it was encountering earlier. In fact, we can just go back and you can see how it expands around it there. But then what happens is that blue area to the northwest up here, that comes in and tries to knock those heights down. It's trying to chisel away at that mound of air. You see that 591 that's there? It disappears. And so Lee starts to gain latitude. You see that? So it starts moving north because the pressure is less. So it moves towards the lower pressure through the steering layer of the atmosphere. But watch what happens as it gets north here. Now we're at 102 hours. This is every 3 hours on the Euro. And I want you to start paying attention over in this area right here, because something extremely important is getting ready to happen in the coming frames. As Lee starts to get north, you think, hey, it might turn on out to sea. But watch what happens. Right here, you see this area right here, this 591 is building in, it's holding strong, keeping Margot away from Lee, separating the two. But then something really important starts to take shape right about here. Look how the 591 gets bigger. Then there is a new height line, 594. That means that this mountain of air through here got taller, thicker. The thicknesses, right? And the anomalies are starting to grow too. It's thicker than the norm. The last, 81 through 2010 anyway, that climatological period. And let's get rid of my telestration, and we see what happens. It gets up there, gets close to southeastern Massachusetts, and then this gets bigger. So let's just go back. Watch how that evolves. That tells me two things. One, that this is what is keeping Lee, for the most part, from just heading on out, because it just can't. It can't come up and run into that. That doesn't work. That's not a physical thing, as they say. And then the other thing that this tells me, if this happens sooner or bigger and expands even just a little bit more, especially this way, then this happens earlier and it could pivot right in and make a landfall. Now, to be fair, the reverse is true too, or the inverse, right? This could be more east, it could be less, and Lee does this little thing here and then it goes like that. Yes, that's true. There's a lot of possibilities, and this is still 6 days out, but we have been trending towards this over the last few days, right? And I can prove that to you. Let's just go back a couple of days here. This is Friday, right? And here's what we were looking at about the same time, and it was way more east. And how, why do we, how do we resolve that? Well, look, there's not anywhere near the ridging to Lee's north and east that we have now. And that's why we get what we get. So if this is bigger, more robust, it's kind of like inflating a balloon out here. If there's just a little bit more air in that balloon, it shoves Lee as it's trying to turn back towards the coast sooner, and it could graze New England with an actual landfall. For those that count everything as if it makes landfall, it counts. I'm telling you, this does not have to make landfall to be a really, really big deal. So we need to watch that. Hopefully, high-altitude surveillance from the NOAA aircraft will help with that. That's a huge Atlantic out there. We can't sample everything, so we're going to have to just wait and see. Every meter in the atmosphere now, the way this is measured is in meters, and people that know meteorology understand that. It's going to count. The thicker that atmosphere is, the more it expands out. That mountain of air out there, the more Lee gets pushed back towards New England. And of course, the inverse is true. If that whole mountain of air is a little bit more east, or it's just a little bit less full, then Lee misses more to the east. But we have been trending in the last day or so more towards New England. And that means, and that is why I chose that thumbnail and title card. It is time for New England to pay attention to Lee. It really is. And I have presented the evidence, I hope, as to why I think that. All right? So make of it what you will. Share the video with people that need to know. Yeah, absolutely. In this case, I will say that. People talk about posting things just for likes and shares, and maybe it boosts some people's egos. I'm trying to help you. So yes, please pass this along, because you guys up in New England, you don't have significant hurricane experience outside of Bob in 1991. That's a long time ago. It really is. We're talking more than 30 years ago, right? Close to it, something like that, right? 30 plus years, yeah. So really pay attention to this. If you are in New England, and of course Nova Scotia, New Brunswick, Bay of Fundy area, absolutely. All right, so let me get this online for you. I will be back tomorrow with another update. We'll see what happens. I'll be posting over on Twitter at HurricaneTrack. As always, thanks for following. For all of us here at HurricaneTrack, that's the team and I. We appreciate your time and attention. I'm Mark Sudduth. I'll be back with more for you tomorrow.